day, students. Thank you for joining us today on the 6th episode of the STEM Virtual Series. I'm Andre Stevenson from the Scientific Research Council. I'm an MIS technician and I'll be your host for this episode in the STEM series titled How to Build a Motor. In this series today, we will build an electric motor. However, in order to do so, we will cover a number of steps related to electricity and magnetism. First, we will cover the basics of magnetism. Then we will investigate the magnetic effect of an electric field. Further, we will investigate how a magnetic field imposes a force on a current carrying wire. And then we will build the motor. Okay, let's review the basics of magnetism. Now, what I have in my hand here is a model of a magnet. A typical bar magnet has two poles, North Pole and the South Pole, colored here red and blue. Magnetic field lines emanate from the poles. Magnetic field lines are regions of space where a magnetic force can be experienced. The direction of the magnetic field lines originate from the North Pole and terminate on the South Pole. Using this magnet as an example, the North Pole, the field lines are emanating from the North Pole to the South Pole. All right, so the field lines of a bar magnet would look like this. Next, we will investigate the magnetic effect of an electric current. Now, a current carrying conductor produces a magnetic field. Using this diagram as an example, if we imagine an electric current flowing from the positive to the negative, the right-hand grip rule can be used to determine the direction of the magnetic field. The grip rule states that if the thumb is placed in the direction of conventional current, then the direction of the fingers will show the direction of the magnetic field. So, conventional current is from positive to negative. So if we place our thumb in the direction of conventional current, then the magnetic field lines would be in this direction, demonstrated by the curl of our fingers. Right. We will now take a look on a force on a current carrying conductor placed in a magnetic field. Using this wire as an example, imagine a magnetic field with the field lines moving towards you away from me. So north, south. And the direction of current as shown on the wire. According to Fleming's left-hand rule, if the index represents the direction of the magnetic field, the middle finger represents the direction of conventional current, then the thumb represents the direction of the force experienced by the conductor. We now have all the components that we need to explain how a motor works. Now, an electric motor consists of a current carrying conductor placed in between two permanent magnets. If we imagine two permanent magnets being placed in this direction with the North Pole facing me and the South Pole facing you, right? And a current flowing in this direction, then the wire would experience a force towards the right. students for joining us in the lab where we will finish our experiment on how to build a motor. The tools that we will be using today are a pair of scissors, a couple of lengths of copper wire, a pair of pliers, a pen, a battery, some paper clips, various tapes, and molybdenum magnets. So our magnets will act as the permanent magnet, our wire will act as the current carrying conductor, our paper clips will act as the commutator, and the battery will provide the power source to generate the current. So we will start by unfolding the paper clips and making a loop to hold the copper wire. Then we'll straighten the ends of the paper clip. After we're finished with our two paper clips, next step is to attach them to the ends of the battery. We start by attaching a paper clip to the negative end, which is the flat end of the battery, because it's easier. You take a piece of electrical tape or any other tape that's available. You wrap it along the ends of the battery. You can place the battery on the table in order to stabilize it. Then we place the other paper clip vertical to the first and attach it to the positive terminal of the battery. Wrap the length of tape around the battery using the scissors to cut the excess. Then we position the paper clips to be parallel to each other as such. To stabilize the motor, we will take a piece of tape, wrap it as such, tear off the other end, do likewise, and we will use this tape to hold the motor onto the table or cardboard paper to stabilize it. Place the battery on top of the tape to stabilize the setup. We will now place the solenoid between the pivots of the paper clips. But before we do so, the solenoid will complete the circuit. This end is the positive end of the battery. This end is the negative end. When we place the solenoid in between the paper clips, it will complete the circuit and current will flow in this direction. Now, a current carrying conductor induces a magnetic field, and the right-hand grip rule can be used to determine the direction of the magnetic field. If the direction of the current is indicated by my thumb, then the direction of the induced magnetic field is shown by the curl of my fingers as such. We will now place the solenoid between the loops of the paper clips to complete the circuit. Now be careful, because upon inserting the solenoid into the loop, a current will flow through the conductor. It's not large enough to damage you, but you may feel a shock. So for safety, you may wear gloves or rubber shoes. Now insert the solenoid between the ends of the paper clips. Now we have a complete circuit with a current carrying conductor, and there's an induced magnetic field. All that remains is to place a permanent magnet in the vicinity of the current carrying conductor, and according to Fleming's left-hand rule, a force will be induced on the conductor. Now, just like the diagram, the magnetic field will induce a force on the conductor, causing it to turn. The conductor will turn about the paper clips. When we place the magnet in the presence of the solenoid, because the neodymium magnets are too strong, they pull the paper clips towards them. In order to mitigate this, we will have to use larger batteries. Now we'll insert the solenoid and see the motor in action. Thank you, students. And just to recap, we covered the basics of magnets, demonstrating that there's a magnetic field around the magnet, that current-carrying conductors generate a magnetic field, which can be determined using the right-hand grip rule, which states that if the thumb is in the direction of conventional current, then the curl of the fingers demonstrates the direction of the magnetic field. We also learned that a current-carrying conductor placed in a magnetic field experiences a force, and Fleming's left-hand rule tells us that if the index finger points in the direction of the magnetic field, that's north to south, the middle finger points in the direction of the current, conventional current, then the thumb points in the direction of the force experienced by the conductor. We combined all these principles to demonstrate how a motor works. Thank you for joining us on this episode of the STEM Virtual Series. I hope you enjoyed the episode and learned about electromagnetism and its effects.